name's Daisy Adams. I'm a DevRel engineer at RISC Zero. And today I'm just going to be walking through a very simple, we call it our Hello World tutorial on how to get started writing in the ZKVM. So just a quick introduction to RISC Zero. Our main product, we are a general purpose ZKVM. It's Rust first, and it's open source. We're not tied to any blockchains. We're not building any L2s. It's just a very general purpose ZKVM. And our second product is Bonsai, a distributed proving service that runs the ZKVM remotely. So if you don't want to run the ZKVM on your computer and you don't want to use, your own infrastructure, then we can provide that for you and run the proofs and generate them for you. So throughout the workshop, I'm probably going to mention some terminology that you may not be familiar with because it's just words that we use to describe some of our pieces of the tech, but don't worry about that. I'll explain it as we go through. So first things first, I hope you guys have Rust installed. I'm just going to navigate over to the Cargo RISC Zero library and get that installed. So if you guys don't have that, go ahead and walk through that with me. So here you'll find 3 main commands that you need to run. You need to install the bin install. Let's go ahead and install. I should already have these, but I'm just going to walk through it. That way we're all doing it together. And then we're actually going to install Cargo RISC Zero. And yeah, that was pretty fast for me since I already have it. Let's go ahead and check the version. So if you just recently installed it, you should be on version 0.19.1, which was actually released like yesterday. And then lastly, let's actually install the Cargo RISC Zero toolchain. And this part might take a little bit of time, but hopefully not too long. Okay, yeah. Then I'll probably just continue on with the rest of the talk. I'm just going to make a new folder for my new project. I'll call this factors, because today we're going to be proving that we know the factors of a certain number. Let's go ahead and cd into that. Okay, that's still installing. So the command to install or to make a new project is cargo RISC Zero new, and then you pass in the project name. So for my project, I'm just going to call it factors. And then it's going to prompt you for a guest name. So this is important because this is what you're going to call your image IDs and your ELF binaries. Again, just for this project, I'm going to call it factors. And now it should be generating a whole template with your guest code, your host code, and everything that you need to run the ZKVM. And this part might take a while as well because it's generating all of that template code. So maybe while it's still populating all of the template code, are there any questions so far about RISC Zero, about the ZKVM, or Bonsai? Yes.
Yeah, just to get your question on the video. So that's better, thanks.
So what constraints are there when writing the verifiable Rust code? Or what can we do, what can we not do and use?
Yeah, so with our ZKVM, it's very general purpose, and we can prove basically any arbitrary Rust code right now. That's what we're supporting. We want to expand to other programming languages. Any program language that compiles down to RISC-V binary code, we should be able to, support that. But right now, we're just very focused on Rust crates, making sure that we're as interoperable with Rust and our ZKVM. So there aren't any limitations that I can think of right now But you may face maybe at some point if you import a RISC crate and that's not compatible yet, that might be an issue, but it's very unlikely because we are compatible with, I believe, up to like 77% of the top 1,000 Rust crates, I believe. We keep track of how many Rust crates, how many Rust libraries we're, able to support and stuff, and it's quite a lot, and we test for that every night as well. Gosh, I was not expecting this to take this long. Yes.
So, sorry, can you wait for the... Thanks.
What ArcWorks?
What's that?
ArcWorks, the library.
ArcWorks?
Rust-based crypto library, very powerful one with hash commitment and all this stuff.
Yes, I believe we are compatible with that library, and I believe we do have some templates that do utilize that ArcWorks as well. Yeah. So whenever you start off with your new template, you're going to be prompted to write in your inputs. And for this case, since we're multiplying two numbers, my two inputs were A and B. And attached to them, I attached two functions, the read function, and that's just telling the host to read this input as soon as it gets passed, as soon as the value gets passed into the host. And then the computation that's actually going to be proven is the multiplication of A and B. And the product gets committed to the journal being a public output in order for you to identify that this was the code that you ran. So some terminology here that I mentioned are guest and host. What are they? What's the difference? For that, I prepared a very short slide. The guest is the guest code that's running inside of the ZK VM. So all of that computation, the product of A and B, that is the only part that will actually get proven. The host is the system that the ZK VM runs on. So for example, my ZK VM is running on my Mac. So my Mac is the host. The way that I like to think about this interaction or this relationship, guest-host, is whenever you launch a VMware instance or a Docker container, the Docker is the guest instance on your host machine. And your host, you're passing in parameters to Docker. So you're telling Docker, I want this number of CPUs, I want this amount of memory. Those are parameters that I'm passing to my guest. And that's exactly what we're doing here in our host code. So in the host, I'm passing my actual values, and these are private. These are not actually being committed to the ZK VM. The only thing that the ZK VM will actually reveal is the product that we mentioned in the guest code. So here I just separated out my code between the prover and the verifier. The prover is, of course, proving that, or it's running the computation 15 times 17. And to make things a little bit more organized, I separated out the receipt from the prover because ideally the prover is not doing the verifying. So here I stored my receipt in a binary file. And I should have it somewhere here. That's another terminology that I mentioned, receipt and journal. So the journal is the part that is public. That would be the 255 or the actual output of the product. And the receipt is actually the stark, how can you say, the stamp that says this is the execution that was ran in the guest program, and here is the proof. And we just, we use this terminology to make it easier to understand stark proofs and, all this cryptography knowledge. So I walked through the prover. Here again, I am taking out the output from the journal, and I'm revealing it in the print line. The verifier is just taking the binary, deserializing it, and then it's checking if it actually matches with the image ID. And if it does, the proof should be valid. If not, it's not valid. Yeah, and I guess I can just run this code since it's already here. First, I need to save the file. Go ahead and run. Oh my gosh. Oh, strange. Okay, so I'm running into some weird issue because like I'm like installing it again and then like I'm running this and I'm suspecting, oh, okay, it's actually done now. I think I'm just gonna exit out of this. I don't know if you guys would want me to walk over this again, but we would do it live together if you guys are interested in that or. Okay, awesome. Okay, so now we have the factors template. Let's go ahead and open that up. So this is what you should have in your entire template. You have the host code, you have your methods, which has the guest code. It should be inside of guest, source, and main. This is exactly what you're provided with. Again, it's just a template, so it's actually right in our inputs that we want to prove. So again, I'm taking two numbers, and they'll both be like unsigned variables, and then we'll read them, and we'll copy that. I do two, and I don't need this line anymore. And let's go ahead and take the product of both of these. Multiple B, and let's expect an integer overflow. Okay. Oh, and then I need to actually commit the product to the journal. And again, this is public output. This is the only thing that will be revealed, which is the product of A and B, but A and B will not be revealed. Okay, so now I have my guest code. This is the only thing that will get proven. Let's go over to the host code. Yes. Well, in this case, the only thing that ZK can prove is computation. So A and B are not computation, and A and B are, as you'll see in the host code, those two will get passed. But I'm not committing the actual value A and B. I'm committing the product of A and B. So those A and B do remain private except the product. So here, anything that you commit to the journal will be public, and anything that's not is private. Okay, so let's go ahead and go to the host code. And now the host, kind of like what I was saying from the beginning, the host is passing in parameters to the guest. So I'm gonna pass in the value, I think it was like 17 or something. 17. I'm just going to comment this line out because we don't need that. And here, this command is actually setting up your environment. So if we read here the comments, the executor environment describes the configurations for the ZKVM, including the program inputs. So here they give us a little like beginner line. We're not going to write input, we're going to write A, and then we're going to unwrap that. And then we're going to write B, because that's the second value. And then, oh, I'm missing one. Okay, I don't need this one. Build. And then we obtain the prover. We have the receipt that already includes the ELF binary that my template set up. And then the output is being retrieved from the journal, which we committed earlier. And let's write a line here saying, I know the factors of A and B, and I can prove it. And then we're going to actually pass in the output. And down here, you'll see that it actually verifies already. But in the final example, I took apart the verifier and the prover because ideally the prover is not the one doing the verification as well. Let's go ahead and run this. Methods. Huh, this is weird. What's that? Yes. It's saying it failed to build the custom command, and I'm guessing it's because I was installing the toolchain, but I never let it install properly. So now it's not finding it. Yes. Live coding, right? Yes.
You go back to the code, and I came in 5 minutes late, so apologies if I missed it. Where you specify the factors elf, like where, okay. That's the program you're proving, right? Like the binary.
Yes, so that's the binary. I'm giving it a name so that my program can identify it. Yeah. So yeah, that's the method.
But, and that was the guest, right? The thing that was, so how does this find out about that? Like, are you passing the path to it? Like, what, how does this host find the guest program to prove?
Oh, so the guest is already here. It just works in sync. So it has a very the ZKVM has a very complicated build process. So it looks for these like keywords to find the guest program.
I guess the question, is it loading it all, like compiling everything into the same like process and then just proving some code? Or is it like the guest is compiled, the host is compiled, and then the host loads the guest? It's the first one.
Yeah, so it's all together. So if you were to compile the guest, it would give you some sort of an error because the host, it's expecting some host parameters. You can't just have a guest. I mean,
So the output is like, yes, the ZKVM host and the guest program that it's going to prove. That's the like output of compiling it.
Yeah. So the output would be compiling guest and host together.
Got it.
Yeah.
Thanks for clarifying.
Seeing this live session, it's really curious to see the jobs running after you compiled the template. Can you maybe please type jobs? I'm interested to see that.
What do you mean? These?
No, in the terminal after the build was failed.
Oh.
Jobs, just jobs.
You mean you want to see the error or?
No, I want to see like the jobs running in the background after you compiled the template.
Oh, not sure. Like you want to see like my processes in my computer or?
No, I like in my mind I just wanted to see why the build failed because other jobs didn't finish, and that's why.
Oh, I see. Yeah.
Yeah. Anyway.
Yeah.
One question about serialization, like, does it support any kind of serialization? Like, is it only Serde? Can you use Borsch or any other serialization?
As far as I know, it's only Serde. It's actually already embedded when in your execution environment. So here, no. So here, when I commit like A and B, I don't need to like add any, translations to that because that's already embedded into the right function.
Oh, okay.
Yeah.
No.
That was actually a new addition that we added recently.
Also, A and B are the circuit inputs, like saying, but like, can you specify them to be private or public? Because you need some public inputs to verify that on chain, and I think that's very, very important for a DApp.
So you're asking like, can I make some inputs private and others public?
Yes.
Yes, in a way that you would only expose the public ones. Again, by committing to the journal. So if you don't expose that information to the journal, then it's just not going to be public. So that's how you can, keep some private and others public by using that commit function.
So you can commit to the environment also, not only the product, which is the output, but also the inputs. Because some circuits don't use outputs. You just have some inputs and you check like integrity of something after calculation.
Yeah, I mean, if you want to commit A and B, you can do that as well. Like yeah.
Okay, I see. Thank you.
So this is all on your machine. Maybe it's not part of the demo, but I was curious what it looks like in the cloud version. Like, do you sort of upload this compiled thing, or do you just upload the guest, or like how do you do that?
Yeah, so we do have the Bonsai proving service, and that is, you can think of it as like a cloud, or it's a remote proving essentially. And there's various methods that you can invoke Bonsai. So you can use the template, or there's this new way where you can actually just pass in Bonsai environment variables, and the Cargo RISC Zero tool will actually pick up that you're using Bonsai. So you don't necessarily need to be on chain in order to invoke Bonsai. You can just use it for any large computation that you want. So let me see if yeah, this is the quick start guide. So it walks you through the entire ZKVM process, which is what I was planning to do. And then at the end, you can then choose to do remote proving instead of actually running the ZKVM on your machine. And let's see.
Yeah, I can see that.
Yeah.
You put your API key and the URLs there in the remote proving part.
Yeah. So here, so here are the 4 methods. So you can use the Cargo RISC Zero tool, which right now is failing for me. And then there's the templates, or you can call the SDK, or you can even use our REST API to call Bonsai. So there's multiple ways, but you do need to have a Bonsai API key in order to use it, and that you would just sign up with a very simple form, and then we would provide you with the API key.
Yeah, super helpful. Thank you.
Yeah, so I have about 4 minutes left, and I just want to apologize for this thing not working. So I'll just go over quickly over what bounties we're offering. We have 3 different categories. Our first one is just build a general app. It doesn't matter what it is. You can either use the ZKVM or Bonsai, and we'll consider up to 5 projects. We're giving away 7,000. So if 5 top projects submit, then we'll probably split the 7,000 for the 5 projects. And if only a couple of them submit, then we'll split those couple within the 7,000. And then the second category is the best ZK coprocessor idea using the Foundry template. And that is on the website. It's a very simple template. Of course, you initiate it and then you build. For this, you would have to build something on-chain or something that connects to the Ethereum blockchain. And for that, we're offering $2,000. And then the last category is $1,000 for the best ZKML project. And we do have a ZKML template that you can utilize for it. But that's all I had. Thank you.